So next I am going to discuss one problem. In the previous class I have discussed some special cases. Most of the special cases are motion on the rough horizontal plane. Next I am going to discuss one problem. Look at the problem on the screen. Once I read out the problem, a pulling force of magnitude capital F is applied on a block of weight 300 Newton at an angle of 37 degrees above the horizontal, and the block is initially at rest on a rough horizontal floor. Then brackets nu s equal to 1 by 3 and nu k equal to 1 by 4. Find the magnitudes of friction on the block and accelerate the block when there are two values of F. Two parts of the problem. First part of the question, F equal to 80 newtons. Second part of the question, F equal to 100 newtons. You have to take G equal to 10 meter per second square and sine 37 degrees equal to 3 by 5. In case you are interested to try the problem yourself, you can take a pause and try the problem. Otherwise, I am going to discuss this problem now. So I am going to solve the problem which I have shown on the screen before. The weight mg of the block is given at 300 newtons. So if you substitute G equal to 10 meter per second square on the left hand side, and you get M equal to 30 kg. Mass of the block is 30 kg. Question of static friction between the block and the horizontal floor is given to 1 by 3. Question of kinetic friction is given to 1 by 4. The angle theta which the pulling force makes with the horizontal is given at 37 degrees. I have discussed one special case earlier on how to find the minimum value of the pulling force required to start the block moving. So the minimum value of the pulling force, in case you remember that conclusion, you can straight away use that conclusion first. The minimum pulling force required to start the block moving if it is initially at rest on the rough horizontal floor, when the pulling force applied an angle theta above the horizontal is given by nu s mg by cos theta plus nu s into sin theta. Here nu s is 1 by 3. The weight mg of the block is 300 newtons. Cos theta is cos 37 degrees, which is equal to 4 by 5. Nu s is given to 1 by 3. Sin theta is equal to sin 37 degrees. That is equal to 3 by 5. Can try to simplify this. If you simplify this, you get 100 Newton. That means the minimum pulling force required to just start the block moving is 100 Newton. Strictly speaking, the block starts moving only when the magnitude of pulling force applied on the block exceeds 100 newtons, just exceeds 100 newtons. Let us consider other forces which act on the block. The weight mg of the block acts vertically downwards The normal reaction force on the block by the floor acts vertically upwards, perpendicular surface of floor and directed away from surface of floor. The pulling force applied on the block tends to move the block towards right relative to the floor. Therefore, frictional force on block by the floor acts towards left side. Can resolve this pulling force into two rectangular components along the horizontal and vertical directions. So I choose the horizontal direction parallel to the floor as positive direction of x-axis, vertical upward direction as positive direction of y-axis. The pulling force can be resolved into rectangular components along parallel to x and y axis. The horizontal component pulling force will have magnitude of cos theta direct along positive x-axis. The vertical component of the pulling force will have magnitude of sin theta, which will be directed vertically upwards. As we have concluded that the block starts moving only when the magnitude of the pulling force applied on the block exceeds 100 newtons. But in the first part of the question, you are given that magnitude of the pulling force is 80 newtons, which is less than the minimum pulling force required to start the block moving. Therefore, when a pulling force equal to 80 newtons, block will be at rest. And acceleration of the block will be 0. The frictional force on the block when it is at rest we call static friction. X component as a resultant force of the block is denoted by F subscript X. You can observe from the free body diagram the horizontal component of pulling force with magnitude of cos theta direct along positive x-axis. Small f represents the magnitude of friction on block by the floor, which will be directed towards left in the negative direction of x-axis. So resultant force along x-axis is equal to f cos theta minus small f. The frictional force on the block can be called as static friction, so I denoted by small letter f subscript s. Because the block is at rest, it has no acceleration along x-axis, so x component resultant force must be 0. Therefore, the magnitude of the static friction on the block same as the magnitude of the horizontal component of the pulling force, which tends to move the block along the floor. Here F equal to 80 newtons, cos theta equal to cos 37 degrees, that is 4 by 5. So you get magnitude of static friction on the block 64 Newton. So for first part of the question, magnitude of static answer is 64 Newton. I mean magnitude of friction on the block is 64 Newton and acceleration of the block is 0. This result which I have written on the left side, minimum pulling force, this can be directly used only in objective type exam papers, in entrance examinations. But in case you are given a similar problem in board examination, you have to first arrive at this conclusion, which I discussed already. I explained you how to calculate the minimum pulling force required to start the block moving in one of the special cases earlier. That working you have to repeat. That means you have to show that first you have to calculate this minimum pulling force required to start the block moving as explained earlier. You have to arrive at this conclusion first and then use the conclusion. But in objective type exam we can straight away use the conclusion. Coming to the second part of the question. In the second part of the question, the magnitude of the pulling force applied on the block is given as 200 newtons, which is more than 100 newtons. As I discussed, the block starts moving when the magnitude of the pulling force applied on the block exceeds nu s mg by cos theta plus nu s sin theta. That means the block starts moving when the magnitude of the pulling force applied on the block exceeds 100 newtons. In the second part of the question, the magnitude of the pulling force on the block is 200 newtons. That means more than the minimum force required to start the block moving. Therefore, the block will be in motion. When the block is in motion, the frictional force on the block can be called as the kinetic friction. To find the magnitude of kinetic friction, we have to first find the magnitude of normal reaction on the block. Let Fy denote the y component resultant force of the block. You can observe, look at the free body diagram. N is the magnitude of normal reaction force on the block by the floor, which acts vertically upwards along positive axis. The vertical component of pulling force with magnitude of sin theta acts vertically upwards. The weight mg of the block acts vertically downwards. So y component of resultant force of the block is equal to n plus f sin theta minus mg. But the block has no motion in the vertical direction. Therefore, y component of the resultant for the block will be 0. There is no acceleration in the vertical direction. So, magnitude of normal reaction of the block will be equal to mg minus f sin theta. Here theta is 37 degrees. The weight mg of the block is given to be 300 newtons. The magnitude pulling force applied on the block is 200 newtons. Sin 37 degrees is equal to 3 by 5. So you can simplify this to calculate the magnitude of the normal reaction. On the block. So magnitude of the normal reaction on the block will be equal to 180 Newton. So magnitude of, continuing the calculation for second problem here on the right side. So magnitude of kinetic friction on the block during the motion is equal to nu k into n. Nu k is given to 1 by 4. Magnitude of normal reaction is 180 newtons. So magnitude of kinetic friction on the block will be 45 Newton. So that is one of the answers, because you are also asked to find the magnitude of friction on the block and the acceleration block. To find the acceleration block, we have to find the resultant force of the block. Look at the free body diagram. The friction force I am denoting by Fk now. The y component resultant force is 0, so x component is resultant force of the block. When Fy is 0, resultant force of the block is equal to Fx. That means x component of resultant force. You can look at the free body diagram. The horizontal component of pulling force with the magnitude of cos theta acts along positive x-axis. Fk represents the magnitude of kinetic friction on the block by floor, which acts to the left in the negative direction of x-axis. So x component resultant force of block, we can write F cos theta theta minus Fk. According to Newton's second law, the magnitude of this resultant force of block will be equal to product of its mass and magnitude of acceleration. Come on, now substitute all the values and simplify and calculate the acceleration. So those who want to copy the working or solution of the problem, they can start writing the solution of the problem. Theta is 37 degrees, so cos 37 degrees is given to 4 by 5. Magnitude of kinetic friction we got 45 Newton. Mass of the block is 30 kg. So 150 Newton by 30 kg is the acceleration. That you can simplify it further. (23 by 6 meter per second square). So those want to copy the solution of the problem, come on, copy down solution of the problem. In case you need more time to copy the solution of the problem, you can take a pause and take your own time. Next I am going to discuss motion of the block down a fixed rough inclined plane. First I discuss the theory part. It is not necessary to write the notes for motion down the inclined plane. As soon as I start the discussion, the notes will be shown to you separately. So let us, next I am going to discuss about motion of a body down a fixed rough inclined plane. Earlier in Newton's laws of motion, I have discussed the motion of a body down a smooth and fixed inclined plane. As I discussed earlier in Newton's laws, the block is placed on the inclined surface of a smooth and fixed inclined plane. When the block begins to slide down the inclined plane with an acceleration of magnitude given by A equal to G sin theta. If the block slides down under the influence of the forces mg and normal reaction. But here we are discussing situation where the block is resting on the inclined surface of a rough inclined plane. The inclined plane is not smooth. So you cannot use this conclusion for this case. Let theta be the angle of inclination of the plane to the horizontal. So there are, here let us consider the force acting on the block. Of course there are two possibilities here mainly. The block is just placed on the inclined surface of a fixed rough inclined plane. The first possibility is that the block may remain at rest on the inclined plane. The second possibility is the block may begin to slide down the inclined plane with some acceleration. We will consider both the possibilities. So when the inclined plane is rough, when the angle of inclination theta to the horizontal is small, I mean less than a particular value, then the block will remain at rest on the inclined plane. Let us first consider a situation when the block is at rest on the inclined plane. So three forces act on the block here. First one is its weight mg, which acts vertically downwards. The second force of the block is the normal reaction force. The normal reaction force on the block by the inclined surface acts perpendicular to the inclined surface and directed away from surface of the inclined plane. The third force of the block is the force of friction on the block by the inclined surface. This frictional force can be called static friction if the block is at rest. Of course, the block tends to slide down the incline due to influence of gravity. I mean, the component of weight of the block, which acts parallel to the inclined surface, will have magnitude mg sin theta. It tends to move the block down the incline. So force of friction on block by the inclined surface acts up the inclined plane. So if the block is suppose at rest, that means we are first analyzing the first possibility. The block is at rest. Then the vector sum, I mean the block is at rest with respect to the laboratory frame of reference, which we consider it as inertial frame of reference. Then the vector sum of all the forces acting on the block must be equal to zero vector. That is F1 bar plus F2 bar plus F3 bar in vector form equal to 0 bar. Means vector sum of the weight of the block, normal reaction force and friction forces by the inclined plane will be equal to 0 vector. That means the vector sum of normal reaction and frictional forces on block by the inclined surface will be equal to minus mg bar. The vector sum are resultant of normal reaction and friction forces on the block by the inclined surface is called as total reaction force on the block by the inclined plane, or you can say it as contact force on block by the inclined plane. That means when the block is at rest on the inclined plane under the action of the gravity and the contact force by the inclined plane, then the total reaction force on the block by the inclined plane in vector form can be written as minus mg bar. The weight mg of the block acts vertically downwards. That means if the block is at rest, the total reaction force, I mean if the block is at rest on the rough inclined plane under the action of its weight mg and contact force by the inclined plane, then magnitude of the contact force between the block and the inclined plane, or magnitude of that is the magnitude of total reaction on block by the inclined plane will be equal to its weight mg, but directed opposite to the weight mg. That means the total reaction force, that means will act vertically upwards, which has same magnitude as the weight mg. The resultant of normal reaction and frictional forces on the block by the inclined plane is called total reaction force on the block by the inclined plane. That means you may show the two forces N and Fs as equal to one force. That is the total reaction force. So if the block remains at rest on the inclined plane under the action of the forces mg and contact force by the inclined plane, then the contact force on the block by the inclined plane which we call total reaction force on the block by the inclined plane, will be equal to the weight mg in magnitude but opposite in direction. That means it acts vertical upwards because the weight mg acts downwards. So magnitude of the total reaction force will be equal to mg. So to estimate the magnitude of the static friction of the block, I choose coordinate axis. I choose the direction parallel to the inclined surface as x-axis, direction perpendicular to the inclined surface as y-axis. You just concentrate only on listening to the discussion I am doing. That means you just concentrate on listening to my explanation. Don't start writing the notes now. I mean, don't write running notes while I am discussing. The notes will be separately shown to you. So those who are interested to write the notes, they can write the notes later. They can just concentrate only on listening to my explanation. The line of action of narrow reaction is produced backwards. The smaller angle between the weight mg and line of action of narrow reaction produced backwards will be same as the angle of inclination theta of the inclined plane to the horizontal. So you can resolve the weight mg into rectangular components parallel to x and y axis. Further, you can construct rectangle with adjacent sides parallel to x and y axis such that the weight mg acts along the diagonal of the rectangle. The component mg cos theta acts perpendicular to the inclined surface and opposite normal reaction. The component mg sin theta acts down the inclined plane along positive direction of x-axis. So if the block is at rest, then the resultant force on the block must be 0. The next component of the resultant force can write mg sin theta minus fs, that is 0. Or you can say magnitude of the static friction of the block is same as the magnitude of the component mg sin theta, which tends to move the block down the inclined plane. So if the block remains at rest on the inclined plane under the action of the force mg and normal reaction and static friction, then magnitude of static friction of the block is same as the magnitude of the component mg sin theta, which tends to move the block down the inclined plane. So you can write and y component resultant force on the block Fy equal to n minus mg cos theta. That can also be equated to 0. Or you can say magnitude of normal reaction of the block is same as the magnitude of the component mg cos theta. So if the block is at rest on the inclined plane, you can say that magnitude of static friction on the block less than or equal to us into n. So in general, magnitude of static friction between two surfaces in contact less than or equal to the limiting value us into n. So you can substitute fs equal to mg sin theta on the left hand side and n equal to mg cos theta on the right side. So you can cancel mg both sides. So sin theta by cos theta is less than or equal to s. So the conclusion is that the block will be at rest on the inclined plane under the action of the forces mg, normal reaction, static friction, if tan theta is less than or equal to us. or theta is less than or equal to tan inverse US. So, as I discussed, the block will be at rest on the inclined plane under the action of weight mg and normal reaction and static friction. If tan theta is less than or equal to US, or you can say theta is less than or equal to tan inverse US. So the maximum possible angle of inclination of the inclined plane to the horizontal for which the block remains at rest on the inclined plane is called angle of repose. That means, suppose if a block is placed on rough plank or rough plane surface, and let us suppose the angle of inclination to the horizontal is gradually increased from 0. The block will remain at rest on the rough plane surface as long as tan theta is less than or equal to US. So maximum possible angle of inclination of the inclined plane with the horizontal for which the block just remains at rest on the inclined plane, limiting equilibrium, is called angle of repose. So angle of repose is equal to tan inverse US. Earlier I have discussed about angle of friction denoted by phi, which is equal to tan inverse US. That means the angle of repose is same as equal to the angle of friction. And for a block resting on inclined plane, you can say inclined surface, the angle of repose is equal to the angle of friction. That means the block remains at rest on the inclined surface if the angle of inclination theta of the inclined plane to the horizontal less than or equal to the angle of friction between the two surfaces in contact. So the block, the component of the weight which acts parallel to the inclined surface has magnitude mg sin theta. The component mg sin theta tends to move the block down the inclined plane. So block begins to slide down the incline under the action of the forces mg, normal reaction and friction. If the magnitude of the component mg sin theta, which tends to move the block down the inclined plane, is greater than the limiting friction or maximum value of static friction between the two surfaces. The maximum value of static friction between the two surfaces is equal to nu N. So the block begins to slide down the incline itself under influence of gravity and contact forces by the inclined plane. If the magnitude of the component mg sin theta is more than the limiting friction nu N, can write here N equal to mg cos theta. On the right hand side, can cancel mg both sides. So the block begins to slide down the inclined plane. If sin theta is greater than US cos theta, or sin theta by cos theta is greater than US, or tan theta is greater than US, or theta is greater than tan inverse US, or theta is greater than phi. So the block begins to slide down the inclined plane. The block begins to slide down itself down the inclined plane under the action of weight mg and normal reaction and friction forces. if the angle of inclination of the inclined plane to the horizontal is more than the angle of friction between the two surfaces or greater than the angle of repose. So even if the angle of inclination theta of the inclined plane to the horizontal is infinitesimally greater than this angle of repose, then the block begins to slide down the inclined plane with acceleration. So once the block begins to slide down the inclined plane with an acceleration, then the frictional force of the block by the inclined surface will be equal to the kinetic friction. The magnitude of kinetic friction on the block with the inclined plane is denoted by Fk. So when the block is sliding down the inclined plane under the action of weight mg and normal reaction Fk, so resultant force on the block will be equal to Fx, that means x component resultant force. Here the block has no motion parallel to the y-axis. So the x component is resultant force of the block will be equal to mg sin theta minus Fk. So if theta is greater than phi, so you have to remember that if tan theta is less than us or equal to us, then the block will be at rest on the inclined plane. Then magnitude of static friction of the block is same as the magnitude of the component mg sin theta. If tan theta is more than us or theta is more than tan inverse us, then the block will be sliding down the inclined plane with an acceleration. Then kinetic friction of the block during the motion is given by Fk equal to nu k into n or nu k into mg cos theta. The nu k is the question of sliding friction between the block and inclined plane. So when the block is sliding down the inclined plane, you can write the resultant force on the block down the inclined plane is equal to x component resultant force, that you can write magnitude of the component mg sin theta which acts down the inclined plane minus magnitude of kinetic friction which opposes the motion of the block. So Newton's second law, resultant force of the block can be written as equal to product of its mass and acceleration. So this you can write it as MA. So if you substitute the magnitude of kinetic friction equal nu k into n or nu k into mg cos theta on the left hand side, then you get mg sin theta by the nu k into mg cos theta equal to MA. You can take mg common outside on the left hand side. So mg into sin theta minus nu k into cos theta equal to MA. So you can divide the equation with a mass m. Therefore, the acceleration of the block when it slides down the rough inclined plane under the action of three forces, mg, normal reaction and kinetic friction, is given by g into sin theta minus nu k cos theta. This formula can be, you are supposed to remember for board examinations, this formula can be directly used even in the subjective problems in board examination because it is a derived result in textbooks. Of course, this formula is valid only when the block slides down the inclined plane only under the action of the three forces mg, normal reaction, Fk. Next, here I am going to show you the summary of the discussion I have done so far. That means I am going to show you the notes for the discussion I have done so far. So those who want to write the notes, they can get ready with your notebook and pen. I'm going to show you the PowerPoint presentation or the notes for the discussion I have done so far. So come on, look at the summary of the discussion I have done. For motion on down a fixed rough inclined plane, whatever I have discussed so far. For motion down the fixed inclined plane, I'm going to show you the notes for that or PowerPoint presentation. So those who want to write the notes, they can get ready with the notebook and pen. They can start copy the heading. So I advise everybody to write the notes and keep a separate notebook for my classes. For those, it's not compulsory, but advice, because writing practice will be good, particularly those who are in junior intermediate classes now. Or listen to the summary of the, if you are not writing the notes, you can listen to the summary of the discussion. Consider a block of mass M resting on the inclined surface of a fixed inclined plane of angle of inclination theta to the horizontal. The block is at rest, then N bar plus Fs bar plus Mg bar equal to 0 bar. N bar means normal reaction force on the block in vector form. Fs bar means static friction on the block in vector form. Mg bar is a gravitational force on the block by the earth or its weight. Those who are writing the notes, come on, start writing. Or you can write N bar plus Fs bar equal to minus Mg bar. The resultant, the vector sum of normal reaction and friction forces on the block by the inclined plane is called total reaction on the block. That means vector N bar plus Fs bar, the resultant of normal reaction and static friction forces on the block by the inclined plane, we call the total reaction of the block equal to minus Mg bar. Come on, write down. Those who want to take more time to copy the notes, I mean those who need more time to copy the notes from the screen, they can take a pause and write the notes. I'm going to show you the continuation for this. This is the free body diagram for the block. The weight Mg acts vertically downwards, you can observe. Normal reaction acts perpendicular inclined surface and direct away from inclined surface. Small f represent the magnetic friction force of the block with inclined plane, which acts up along the inclined plane. Resolve the weight Mg into components parallel to the inclined surface and perpendicular to the inclined surface. The component Mg cos theta acts perpendicular to the inclined surface. The component Mg sin theta acts down the inclined plane. I choose the direction parallel to the inclined surface down the inclined plane as x-axis. Direction perpendicular to the inclined surface as y-axis. So if the block is at rest, then Fy, y component resultant force N minus Mg cos theta can be equated to 0, or N equal to Mg cos theta, magnitude of normal reaction. Next component resultant force equal to Mg sin theta minus Fs, that is equal to 0, or magnitude of static friction of the block is same as the magnitude of the component Mg sin theta. Come on, those who are writing the notes, they can come on, write down the notes. That means I am just whatever I have already discussed, I am showing it. The typed form or PowerPoint presentation of same notes. But Fs less than or equal to Us into N, you can, when the block is at rest, you can write Fs equal to Mg sin theta on the left hand side and N equal to Mg cos theta on the right side. So Mg sin theta is less than or equal to Us into Mg cos theta. Therefore, sin theta by cos theta is less than or equal to Us. Those who are copying the notes, come on, write down the notes. In case you need more time to copy the notes, you can take a pause and take your own time to copy the notes. I am going to show you the continuation for this. Block will be at rest on inclined plane under the action of forces mg, comma, n and fs. Fs means static friction. If tan theta is less than or equal to s, or theta is less than or equal to tan inverse s, or theta is less than or equal to phi. Here phi is the angle of friction between the two surfaces in contact, which is equal to tan inverse s. So then I have given the definition for angle of repose here. The maximum possible angle of inclination of the inclined surface to the horizontal, for which the block will be in equilibrium on the inclined plane, is called as the angle of repose. Angle of repose equal to tan inverse s. Come on, copy down the notes. So I will show you the notes continuation of these notes in my next class. You can finish writing the notes up to here. In my next class, I will be showing you the continuation for this.